Okay, this is the lecture for European history for Tuesday, the 2nd of November, 2021. David.
A boy walks up to a girl and he asks her, "Hey, would you like to be the sun of my life?" The girl responds, "Aw, yes." The boy then says, "Good, then stand 93 million miles away from me."
I like that. It's the astronomy thing. It's 1 AU, or aw. Okay, as joyous and wonderful as that is, you have a pass?
There's the
Good. See, I will tell everyone, I told her not to be late, and yet she's late. You should have told me that. But no, you walked out all silent like.
I did.
And mysterious.
I did. She's grabbing her backpack.
That's nice to know. Yes, we start our lectures sharply and energetically. We were talking about Prince Henry the Navigator, the Portuguese prince who establishes his school at Sagre, bringing together astronomical navigators, experienced sea captains, and shipbuilders. The graduates of his academy are going to do wonderful things, and they're going to set the stage for maritime and naval academies afterwards. But before we go into the achievements of the Portuguese, we are going to look at the technology. We already looked at the magnetic compass, one example of which is this magnetized needle floating on a cork in a glass, which is going to tend to aim at magnetic north, and in doing so allow us to know not only north, but south, east, and west, cardinal directions. It is fortunate that the Earth has a unified magnetic field because it blocks out cosmic radiation. Mars, let's put it in the shelf, does not have a unified magnetic field, and Mars, therefore, is a basket case. And if we ever settle the planet, we're going to have to deal with extensive cosmic radiation. So, the compass gives us cardinal directions even when we're at sea. Then we talked about the sextant, or the astrolabe. The sextant, or the astrolabe, is an angled set of slats. The lower slat has a plumb bob hanging from it, and a 90-degree angle on the plumb bob to allow the people using the sextant to get a sense of the local horizon, local down, local level. Why do you have a calculator out? Oh, okay. There's a banana clip-shaped object which has degree marks, and then there's the upper slat on the hinge, which has a sight. And if you're sighting, for example, on Polaris, that's what that represents, Polaris, which is the North Star, you get a sense of what distance? Have your notes out. What distance? What direction?
Longitudinal distance.
The other one.
Oh, latitude.
Latitudinal distance. And latitude is in what two directions? What two directions? En español, señorita? Norte y sur. Yeah, I think. North and south. Thank you. Don't ask me why I did that. I voted today. I always am excited on election.
Who did you vote for?
Good question. But knowing me, you shouldn't have any question.
No, yeah, I know.
Especially since I publicly announced it a couple of weeks ago in the newspaper. For local politicians.
The newspaper.
The newspaper. So, yeah, exactly, old people.
Old people.
So, there's the upper slat and it aims up and it tests north-south distance. So, if every night I am using Polaris to fix my location, and every night Polaris is getting lower in the sky, in what direction am I moving? Yes.
South.
Right. Because I'm moving away from Polaris. If it's going higher in the sky, I'm moving north.
What's Polaris?
Polaris is the North Star. It's the star right above the North Pole. Now, we are so lucky not only to have a unified magnetic field that is roughly harmonious with our axial, with our axis, which is what magnetic north is in relation to true north. But we are also ridiculously lucky in terms of Polaris. Polaris provides a reference point that gives us a notion of true north. The odds against having a star in such a fortuitous position where you can just see, oh, that's north. So you don't even need a compass at night if you know where Polaris is. Use the Big Dipper's front two stars, you sight along it to the first bright star along that line, there's Polaris, and what do you got? You have north, if you're north of the Tropic of Cancer. If you're not, then it becomes harder and harder because Polaris becomes more difficult to see. Below the equator, impossible to see. But now we have two dimensions of the problem relatively solved. We know what directions are, and we know our line of latitude, which is how far north or south we are. But there's a problem with the other dimension. Sam?
I was just wondering how they determined that Polaris was like perfectly north from these locations. Like how?
I think functionally. I think basically, remember, ancient peoples cared much more about the nighttime sky than we do because their very lives depended upon it. Remember, to the ancient Babylonians and to the medieval Mexicans, the nighttime sky told them the calendar, when to plant, when to harvest, that sort of thing. This is why early civilizations always build stone megaliths in harmony with the heavens. The Great Pyramids, the ziggurats of Mesopotamia, the Aztec pyramids, the Mayan pyramids, Stonehenge, all of them and many more are built as giant calendars. And using the nighttime sky, the heavens, the planets, not so much the planets, the stars to measure time. And it was a secret mystery. So
they had determined that no matter where you were on the planet, that was always like north.
Right. As the heavens wheeled. I mean, they may not have called, they may have just said Polaris word. But no, somebody noticed that. Because what they did is they charted the heavens. I mean, our concept of constellations is purely subjective. No genuine space traveler would ever use constellations as their points of measure because constellations are purely a matter of perspective. I mean, right now you can see me, I can see you, but now I can't. But now I can. But now I can. Now I can. Now I can. Now you can see me on both sides, but not in the middle. Unless I do that, it's all about perspective. To those of you at home, I'm showing myself and hiding myself from a person directly behind the chair holding this camera.
Say hi. Hello.
There we go. So, there's a reference point. But the east-west distance is going to be much more of a conundrum. When dancers learn to spin, they learn to spin, and I'm not doing this fast because I don't want to hurt my neck. I'm old.
Oh no.
They learn to spin by keeping their head affixed, eyes on a point, and their body spins. Yes, I'm not a good dancer. I know this. Now I'm doing it backwards
Can I
because
try?
I'm not a good dancer. I'm sure you do wonderfully. What?
We used to do that in Taekwondo when like doing spinning kicks
Yeah.
and stuff. It's just called checking.
Yeah.
And so like you like make sure that your face is always somewhat towards.
And it's a good idea. It's certainly better than getting dizzy, which is what would happen if you didn't do that. Even with doing that, you're still going to get dizzy if you twirl. That's just part of the nature of the beast. Is there an object in the heaven that's fixed that'll tell you how far east or west you are? No, because you're spinning. Nothing's fixed. Everything moves, except Polaris. And Polaris just tells you north. So there's no object in the heavens that is going to give you east-west distance. How to figure it out? Well, the answer, my friend, is time. Time is a dimension that is going to help us determine longitude, which is east-west distance. Here's how we do it.
I'm trying to hypnotize us.
Here I am. No. Here I am in Greenwich, England, part of London, suburb, and the British Empire is the dominant global empire for a couple of hundred years. Napoleon wanted Paris to be the heart of it. In fact, if you go to Paris, you can see their longitude lines for their prime meridian. It doesn't really matter because he lost. Britain won, the English-speaking peoples won. So, we're in Greenwich, England, and I'm going to go around the world. I can't go completely around the world, though, because I have tables there, but we'll make do. So, I have a clock, a really good clock, a clock that uses springs, a clock that's on a bunch of swivelly things. We got the swivelly thing that goes this way, we got the swivelly thing that goes this way. If you've ever played the Mass Effect game, you see the swivelly things on the Mass Effect relays. And all of this is designed to keep the clock from getting disturbed by the motion of the waves. This is a really good clock. Making really good clocks is not easy. Most clocks have pendulums. What if I want to use a pendulum clock? Well, there's a problem. I've got a clock. I'm at dock. Dock and clock rhyme. This is not a crock. I then get out and go down the Thames River towards the English Channel, or towards the North Sea. And in the North Sea, the waves are getting bigger. And everything, and then the ocean, and then the storm comes. And you are not seeing regular pendular movement, are you?
No.
No, because wave action.
Wow.
So you need a clock with springs and gears and gears and springs, which the Swiss developed and the English buy, and others buy too. The answer is time. And when we develop a good clock, this is the method of determining longitude. It really isn't perfected until the middle 1800s. I'll say that again. The middle 1800s. So that is, let's see, 1500s, 1600s, 1700s. This is 400 years. 400 years into the age of discovery, and we finally perfect longitude. And it has to do with the quality of the clocks. A clock like this, that's designed to be shielded against wave action and that's spring operated with gears, is called a chronometer. A chronometer is a measure of time. It's a chronometer. No, it's a chronometer.
That means that I'm a chronometer. If I was to like tell you time.
That deals with color, as in chromatic. On chronometer. Then there's the incrementometer, which is the measuring of tiny little increments. I'm joking. So, you have a chronometer. No. You have two chronometers. And they're going to be matched up. And they both go in the most protected part of the ship. Now, one clock is synchronized, actually both clocks start out synchronized towards noontime, Greenwich Mean Time, which is the noontime at Greenwich, England, which is a suburb slightly east of the center of London. Then I go out to sea. I'm going to cross the Atlantic. Now, this clock stays on Greenwich Mean Time. This clock, every night, or every day, probably every night, at midnight, is going to be set to local midnight or local noon. So, this clock is constantly reset to one's local position because local noon and local midnight vary. This clock remains at Greenwich Mean Time. So now I've traveled about a quarter of the way around the world. I am probably on the eastern seaboard of North America somewhere, maybe near Florida, I don't know. What's near 90 degrees, Miss Crawford? Behind you on the map. Look, no, there's a map.
Right.
Left, left side 90 degrees. Can you point towards the line? Left of the center of the map. So you go there. Okay, so left, down at the bottom it says 90 degrees somewhere. See those little degree markings? So what's... Aha! Okay, so I'm west of Chile. I'm actually near New Orleans. Okay, so I've gone from London to get some gumbo in New Orleans. I am roughly at 90 degrees west longitude. So, if it is noontime in Greenwich, England, what time is it at New Orleans?
I'm sorry, is this one?
Quarter of the way around the world. 90 degrees
12:45.
west. Yes?
Wouldn't it be 8 a.m.?
Let's see. 8 a.m.? Or would it be 6 a.m.?
Yeah.
I think a quarter of a day is 6 hours.
Yeah.
Oh, no, I appreciate it. Now, why is it a.m. when it's noon over here? Well, from a relative position, what direction does the sun rise in the morning?
The West.
Rises in the east, sets in the west. Y'all are meant.
Charter Academy students.
We are the.
I
smart
realize it's
group.
basic information. The sun rises in the east.
Oh, wait, that's
So, it's noontime in England. It's 6 a.m. in New Orleans. Quarter of the way around the world. Then, I keep going. I'm going south from New Orleans through the Panama Canal and across the Pacific to 180 degrees west latitude or 180 degrees east latitude. This is otherwise known as the international date line. I am somewhere near Kiribati, which are the Gilbert Islands. Okay, so now I'm at 180 degrees. East or west, it doesn't matter, it's 180 degrees. If it's noon in Greenwich, England, what time is it here on the opposite side of the planet? Noontime. Halfway around the world. What's half a day away from noontime? Well, what? PM, which is?
AM, actually. It's actually in the AM.
It is midnight. Well, it's 12. Yeah, whatever. You're right. 12 a.m.
I'm right? Did you just say
I liked your answer. Yeah, that's okay. She guessed it. She
Good job, Drew.
did her job. I honor that. Thank you. It is midnight in the mid-Pacific.
Someone called midnight.
Noon, midnight. Mind blown. Why? Because we have a round world. Now, suddenly, watch this. I'm going to go.
No, it's a try.
And I'm gone, 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 I'm gone.
Oh, whoa.
Here I am. Wait. There. On the other side of the world. Now I'm on the other side of the world. Damn! Hot. And I'm going to keep going in the same direction. So I travel from the Central Pacific through the Malay Barrier to Calcutta, India, which is about 90 degrees east latitude. It's still noontime in Greenwich, England, or it's noontime again. What time is it this way?
Wouldn't it be 6 p.m.?
It would be 6 p.m., 6 in the evening, because in Calcutta, I'm a quarter of a way later than I am in England. So it's noontime in England. It's 6 p.m. in Calcutta, India. It's 6 a.m. in New Orleans, Louisiana, United States of America. And it's midnight in the Gilbert Islands or Kiribati near the international date line. So, not bad. All you need, and I sail back around Africa or through the Suez Canal, and I'm back here in merry old England at Greenwich, and my local time matches the time I'm spending. The local time is matching Greenwich Mean Time. So time is the answer. But time requires exactitude, precision. Precision clocks do take those 400 years to build. So I will point out to you the lovely maps that I have been displaying here for years in front of my classroom. And you will see that there are some distortion. First of all, we thought California was an island. We thought that
It should be,
that the
yeah.
Baja Peninsula connected to the area of Washington near the Strait of Juan de Fuca, and that California and the Pacific Northwest was one big island. If only. So, this map here, And this map here, gosh, don't they look like a carnival mirror distortion? You see the two maps. But I'm going to tell you something before I take questions. What I'm going to tell you is these maps are extremely accurate in terms of latitude. In terms of north-south distance, Santiago de Chile, Santiago de Cuba, Santiago, Mexico, I don't know, or Texas. There are plenty of cities of the Saints. Those are properly placed in terms of north-south distance. What people did is they knew cardinal directions. They had dead reckoning, which they could guesstimate the size of continents and the distance between, and they knew precise north-south distance. So these maps are extremely accurate, except in the dimension of longitude, except in the dimension of east and west. It is only in terms of not being able to find proper east-west distance that, for example, South America looks so distorted. North America looks so broad. Because we can't yet measure it with precision. It really isn't until we develop good maritime chronometers that we're able to do that. Yes?
Let's say, hypothetically,
Hypothetically.
if we had this really, really big saw, could we, like, saw off California?
No. God may do that with a giant earthquake, but that would be a bleeping disaster. I don't wish that on anyone. Also, we would get flooded with refugees if that happened.
We already are.
And I don't know, no. People that are coming here now are people like me who are conservatives who are coming here to be in a conservative area. If there's a giant earthquake, you get everyone who survives.
No, it doesn't have to be an earthquake. I'm just talking about, like, a big saw.
Yeah, no, that's God's earthquake. God's saw is the earthquake. No, what you do is you do whatever's necessary to make California a two-party state again. But I don't know. They decided to keep Gavin Newsom. So what do I know about California politics? Yes.
So in the three maps that are to my right, they're technically your left. But yeah, those.
Yep.
Why is there, like, around the Washington area, there's just not a line and it just goes straight across? Where the map makers just like, well,
They didn't know what was there. They hadn't yet charted. The coastline north of Seattle, near Vancouver and Victoria and all of the islands, was very difficult to chart. Lots of shoals, lots of rocks, lots of mountains under the sea. And so basically they left it sort of blurry. Like on this map here, they just didn't know. They hadn't charted it yet. But they had found something like Alaska here or whatever. So that's why. Also, you will notice a giant South America, a southern continent called Terra Incognita Australis. Terra Incognita Australis is the unknown land of the South. Terra Incognita Australis was what people believed existed because they believed that you needed proportionality between the amount of land in the northern and southern hemispheres. They actually believed that there was proportionality. So in order to have as much land in the southern hemisphere as in the northern hemisphere, they imagined this gigantic southern continent, and all that's there is the island of Antarctica, which is not nearly as big. So, time is the key there. Any questions on that?
why is it not 12:45?
Yes.
Why is it not 12:45? Like, where would it be 12:45?
When is
15 minutes from Greenwich, England.
That's not true.
Okay.
I mean,
like,
yeah,
You tell me, if it's 12 noon in Greenwich, England, where is it 12:45? It's 45 minutes away from Greenwich, England. The thing is, nobody does that because we measure, since the 1800s, we measure time in 1 hour increments. So what we are in right now, what time zone are we in? People, 3, 2, 1.
Pacific.
Yes. What time zone is Boise in?
Mountain.
Idaho is split between 2 time zones. Now, we are in the Pacific time zone. What that means is, if we went from here to Boise, there's an hour difference. If we were on Mountain Time, whenever we went to Spokane, we'd be an hour difference. Yes?
Why did you change BST to China?
I'm sorry?
So in England, they changed the time zone title to from BST to GMT.
British Standard Time to Greenwich Mean Time.
Why?
What does that mean?
I don't think it means anything except they're trying to be more international. I don't know the event, so I can't tell you.
Real dumb.
What I can do is I can assume that there are people who really think that it matters to be less British and more international, and they made the decision. But I don't know. Did I see another hand? Yes.
It annoys me that Boise is in mountain time, yet they're really not any further west than
Seriously.
we are.
There you get into politics. You want to see something really funny?
Oh no.
The Chinese Communist Party makes everyone in China use Beijing time.
Yeah.
So, you've got people north of western India, in that area, which is now western China, that use the same time. And they are about what? They're not a full 90 degrees. They're about 40, 45 degrees apart. So their local time is 6 hours off. But everyone uses Beijing time. Politics.
Why?
nasty.
It's not even in Beijing.
Beijing is the capital of China.
Yeah, but it's not even not China is not in Beijing.
Beijing?
It is according to the time police. And yes, they have time police. Moving on. So,
It has a J in it, so why would you call it?
what we now have is a question of ship types. The Dragon Viking longships that the Vikings used in their raids morphed into this giant round ship called a cog. Now, a cog was the standard merchant vessel used in the Baltic Sea region and in the North Sea region by the Hanseatic League. A cog is not called a round ship for nothing. It has a pronounced rounded hull, and its dimensions on the other side are also round. So this thing wallows like a pig in the water. What that means is it takes on water through its low dimensions there. However, I'm talking over distracted people. However, the cog carries a huge amount of cargo. So a cog is useful in the relatively sheltered waters of the Baltic or of the North Sea. However, if you were to try to use a cog in the Atlantic, it would be a suicide pact. The cog cannot handle the waters of the open Atlantic Ocean. It just can't. So, the Portuguese develop a ship type that has some influences of the Arab dhow, which is a large rowboat that the Arabs use with a triangular or lateen sail. And they adapt it and morph it to some more European designs, and they come up with a ship called the Caravel. Where the cog is round, the Caravel is sharp. Where the cog has a round dimension, if you look at it from the front, the Caravel is very angular. The cog forces its way through the water. The Caravel slices its way through the water. And the Portuguese Caravel has 3 short masts, foremast, which also includes sails that go to the bowsprit here, and a lateen sail in the back, which is useful for maneuvering. The Caravel requires a very small crew, but it's large enough to carry supplies. It has a shallow enough draft to go into shallow waters without running aground easily. What I'm saying is the Caravel is the perfect ship of exploration. And 2 of Columbus's ships were Caravels. And the Portuguese used Caravels. And even to this day, there are people in sailing ships who use designs akin to the old Caravel. So, by developing the compass, you get cardinal direction. The astrolabe, you get north-south direction or latitude. By developing the chronometer, you get longitude. And to be clear, there is a most important line of longitude. And that most important line of longitude goes through my lousy map.
Can I guess where it goes through?
Yeah.
Britain?
Very good.
Wow, so smart.
Oh, we're good, yeah.
It goes through Greenwich, England, which is a suburb of London. That is outsized and really badly drawn. But you get the idea. So now we have all the tools we need, except one. What happens? What happens if the Europeans encounter hostile people?
Oh, that's
Well,
Stab.
Europe took the Asiatic invention of gunpowder, which was used for ceremony fireworks, and rocketry, fairly not great weapons. The Mongols had rocket guns at the
I want a
end.
rocket gun.
Sounds good, but it didn't actually work. And what the Europeans developed are gunpowder weapons in what is called the Gunpowder Revolution. Now here's a simple diagram of a cannon. So how does it work? You've got a solid metal tube, strong enough to handle sudden pressures. Into that tube, you put a wad, which is paper or cloth, something flammable. And inside the wad is a measure of gunpowder, which is a mixture of charcoal, saltpeter, and
Are you telling us how to make gunpowder?
yes, I am. It's a good thing to know how to do.
Ready? Chocolate.
Chocolate, saltpeter,
oh yeah.
chocolate. Yes, that's it. Charcoal, saltpeter, and orange sulfur.
Yeah.
Yeah, sulfur, saltpeter, and chocolate. In proper proportions, you get gunpowder.
You have to be proper.
So, you put a measure of gunpowder and a wad into the back of the barrel. Then you load a lead ball, or a steel ball, or a rock, or a bunch of chains, or some silverware, or whatever. We're going to use a good lead ball, lumph, and you push it in with a ram. So they're both there. Now, you got a hole, which I should probably actually move backward a little bit. It's not quite in the right spot. Okay. So, what there is a hole here through the cannon. And on top of the hole, you've got a little bowl, and that bowl has some gunpowder in it. Now, what you do is you create a spark up here. You can do it with flint. What they prefer to use with cannon and early guns is called a slow match. You take a nice thin piece of string and you soak it in urine enough for it to basically take in certain chemicals, and it will smolder and burn slowly like a candle wick without the flame. You can light a slow wick and 30 minutes later, touch the burning part of it to your gunpowder flash pan, and it'll ignite. Even in the rain, a slow burning match can work. So, you apply fire to this gunpowder, which sends sparks into this gunpowder, which causes the gunpowder to explode. Now, the thing about explosions are like most people. They will follow the path of least resistance. So, we have resistance, 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 unless it's a badly made cannon, in which case everyone nearby dies.
Oh yeah.
We had during the Civil War, the American Secretary of the Navy was nearby when they were experimenting with a new kind of cannon, and he was killed, along with a bunch of other people, when the cannon exploded. So you got to be really careful to have this, the right amount of strength. But the only way that the explosion can go is this way, really fast. The air is expanding. The pressure wave is enough to take that cannonball and by main force shove it out the front of the cannon really, really fast. Now, if you get hit by that, it'll cut you in half, unless it's lost so much range that it starts bouncing and flying across the battlefield. If you fire a cannon at a castle wall, it will crumble. If you fire a cannon at ships' sides, they might be holed. So cannon become very useful, and they eliminate castle construction. A new type of castle or fortification begins to be built with low, thick walls rather than high, thin ones, because cannon make ridiculous work of the high, thin ones. You know?
Okay, so like this is a genuine question.
Just go ahead and ask. Just ask.
So like if a person was to go inside the cannon, would like the explosion kill them?
Yeah.
Going out?
Unless they're in a circus, in which case they're the man who gets shot out of the cannon, which is an actual act. But it's not real.
Oh.
Just like air.
There's the guy gets shot out of the cannon. It's like every other magic trick you see. There's a way of doing it and living. No, a normal person wouldn't survive.
Except in the Secret Life of Pets 2, when the monkey gets shot out of the cannon and there's like fire.
What are you talking about?
The Secret Life of Pets 2, does anybody know what I'm
The
talking
Secret
about?
Life of
Yeah,
Pets.
and the monkey is in the cannon and then the guy's like, here you go, he's like, and then he's like,
Okay.
afterwards.
That's like Scrat splitting a glacier in Ice Age by trying to pack an acorn into the ice, which is lovely. Now,
What about Alex?
if this were a handgun, yes.
So I read on the 4th of July a long time ago they would put weeds in the cannon and like shoot the weeds in the air.
Interesting.
Why?
Did it burn in beautiful ways?
I don't know. I think they just did it to shoot things.
Well, I admit, shooting things is very fun. I enjoy shooting things.
And everybody would
Checks
run
out.
around in the rain.
Yeah.
What type of things are we talking
By the way,
about?
the city of Halifax, Nova Scotia, in World War I, was and still is a place where a lot of American shipping gathers before it crosses the Atlantic. There was a British ammunition ship there because Canada is part of the British Empire at that time, ready to go across the ocean and arm the troops of the British Empire. And in the middle of the night, there was a horrible accident, and this ammunition ship exploded. Now, Halifax is basically a bowl built around this harbor, and most of the city was destroyed. And a good proportion of the city's population was killed instantly, and a number of other people were killed by shrapnel, by fire, by being trapped underground, under rubble. It was one of the worst disasters ever to happen, and it was because gunpowder was not handled properly. A war started because gunpowder was not handled properly. The USS Maine, a second-class American battleship, was touring Cuba to deter the Spaniards from being too rough with the Cuban rebels. In the middle of one night, it exploded. What we now think was that coal dust spontaneously combusted in the Cuban summer heat, which is entirely probable. But at the time, newspapermen who wanted to sell newspapers said, well, it was the Spanish, and we declared war. And we took Cuba from them, and Puerto Rico, and Guam, and the Philippines. And it was the beginning of the rise of America onto the world stage. But it began because of a gunpowder mistake, probably due to coal. Yes?
Oh, I was going to say with Halifax and Nova Scotia. Wasn't that during the day?
It may have been during the day. I thought it was
Okay,
at
because
night.
I watched a documentary on it with my
Okay,
mom.
then I'll defer to your wisdom.
Over the summer, it was really interesting.
Oh, it's horrific.
They recreated, like
Yeah,
like
yeah.
CGI and stuff. And how they literally didn't see two ships they were going across the harbor, and the one ship they literally didn't see the other ship, which was crazy. So they kind of ran into each other, and then it caused all of the leaking, and then there was fire, and then it exploded.
It was an atomic bomb-sized explosion. Not a hydrogen bomb size, but atomic bomb. Amazingly horrific. Now, if you were to do this with a musket, you have the same basic principle, but a musket has a piece of flint on a swivel that's attached to a spring. And what the flint does is it hits steel right over the firing pan, creating sparks and causing the musket to discharge like that. Gunpowder is going to be the key to allowing small European crews to survive contact with large numbers of ornery natives. So all of these things together make it possible for Europe to go out into the world. Now, the Portuguese who were trained by Henry the Navigator's school at Sagre. The big problem, I mean a huge problem, is a place on the North African coast. Please swivel here.
Hello, beautiful.
Or chessboard. Oh, you have a chessboard.
Let's get out.
Chessboard. That's good.
Called Cape Bojador, right about here. So, what's wrong with Cape Bojador? Well, what it is there is a combination there of rocks going off the shore, of a persistent northward current along the shore, and of persistent northerly winds, combined with some of the worst storms in the world. You have hot, dry air from the Sahara, meaning hot, warm, moist air from the Atlantic. This is where hurricanes are born. Some of the worst storms on Earth are in the seaways off of Western Africa. So, for 1,000 years or more, Cape Bojador is the farthest anyone from Europe or the Mediterranean could get down the African coast. People tried and tried and tried and tried and tried, sometimes for weeks, sometimes for months, and they couldn't make headway. The combination of wind, current, and rocks made it impossible. There might as well have been a giant wall made of adamantium with blasters on top of it. No one gets past Cape Bojador until the early 1400s, after Henry the Navigator's school begins to encourage people to think outside the box. Soon, what happens is instead of going down the coast, the Portuguese sailors go way out into the ocean. And by going way out into the ocean, they avoid the stormy coast. What begins to happen is every year during the season of sailing, Portuguese ships would get farther and farther and farther, even into the Gulf of Guinea here and the Guinea coast of Africa, which is like the underside of the chin if you look at Africa like a head looking left. Every time a Portuguese ship had to turn around and go home because they ran out of supplies, they would build a stone cross on a prominent cliff, and they paint it white. And these great crosses every year indicate the farthest that last year's expedition got. Now, this map does not convey the immensity of the African continent. Africa is incredibly huge when it comes to its north-south dimension. This map scrunches it because it's in the center. This map distorts things in the north and the south, and it scrunches things like Africa. So it takes over 50 years for the Portuguese to finally even approach the southern dimension of Africa. And that's where we're going to leave it today. Thank you for your attention. Are there any questions, comments, or thoughts? Haley.
So why do they make it like super big? Is it just because it's supposed to be in a sphere and it's like not in a sphere?
Yeah, whenever you make a round object flat, you're going to distort it. It's like, have you ever taken silly putty and put it over a newspaper photograph and then pulled it and you see it goes all distorted? It's the same thing. That's the way map makers do it with the Earth, except they do it with math. Because math is the most dangerous weapon of all. Math is what made the atom and hydrogen bombs. Thank you for your attention. You may talk quietly among yourselves.